as a P3. It's a pure paper, not a stats topic.
Okay.
All
We
right.
use the formula in it. Okay.
All right. Okay. So let's first talk about indices. All right.
Okay.
So there are several rules of indices. So for example, you have a m plus n in your m plus n is in your power. Yeah.
Okay.
How do you open this up? You do a to the power m into a to the power n. So the bases remain the same. By bases, I mean a. How do you expand this? You take the same bases and you multiply them, separating the powers. Understand?
Yeah.
Yeah. A minus n. So there's a minus in the power. So this would be equated to am upon an. So the bases remain the same and they get divided. But this is not equal to am minus an. This is not equal to this. Why? Because over here the power the am minus sign is not in the power. Yeah.
Yeah.
The minus sign has to be in the power for it to be divided. Then we have am, and then there's a whole bracket to the power n. In this case, the power will become multiplied, so it becomes mn. Yeah. There's another example given where you have am plus n. There's a whole bracket to the power r. So now the power will become multiplied with the r. So it becomes amr plus anr. How can you further expand this? You can further expand it from the rule 1. Yeah, can you see the similarity? So it can further become amr into anr. Yeah.
Yeah.
Then you have a to the power m upon b to the power m. So you can take the power common, which becomes a upon b to the power m. Then you have am into bm. So the bases are different now. So what you can do, you can just multiply the bases and take the power common. Yeah.
Yeah.
Have you written these down?
No, almost done.
Let me know once you're done.
Okay. Okay, done.
Done?
Yep.
All right. I'm giving you some questions for indices, which you can try solving. How would you expand this?
2 to the power 3 into 2 to the power a.
Yes. So it will be 2 to the power 3 into 2 to the power a, which you can further solve 8 into 2 to the power a. Yeah.
Yeah.
All right. Can you try solving this?
Yeah.
What will you be doing?
So it would be 3 to the power m. No.
Yeah. M,
3 to the power m and n.
M and N. You will you multiply the power?
They're
Can you
different.
see
So,
this is basically the opposite of this? So now you're going from here to here.
okay.
Yeah.
Yes.
So it will be what? 3 to the
3 to
power
the
m
n plus
plus
n.
n. Yeah.
Yeah.
Try solving this.
So we'll take 4 as common.
How do you take 4 common?
Like, okay.
Tell me
I
step
don't
by step.
know. 4 to the power a plus b, but then that's 16.
The first step would be to convert this into 4.
Yeah.
Yeah. So to convert this into 4, this would be 4 squared into b. Yes.
Yeah. Yes.
Then according to this rule, this one, the third rule,
Yeah.
powers
Which
become
is,
multiplied.
yeah.
Okay. So the powers become multiplied. This means 4a into 4 2b. Then according to the first rule, it will be a plus 2b. Yeah.
Yeah. Got it.
Okay.
This would be 5 to the power c minus a.
Minus a.
Yeah.
Yes.
We write this as 4a into 5 to the power minus a.
4 into 5 to the power of minus a. Then what?
Yeah. Isn't that it?
No. Look at the rules again.
Yeah. Uh, 4 a 4 over 5 whole to the power a.
Yes. So you take the power common. Yes.
Yeah.
All right. Now I'm giving you some questions to do on your own. All right.
Okay.
It's important to know indices very well before moving on in this chapter.
Okay.
All right. Let me just write down the questions over here. Did you try doing questions from binomial, the polynomials, and everything?
Yeah, I did.
It's okay if you didn't even. You can take your time, but try to do them so we know you're clear with the topics. All right.
Yeah, I completed them.
Okay, that's great.
Yes. In fact, there was a question from one of the lessons of partial fractions, which we had to discuss, but I guess we forgot about it.
You can send me the question. I can have a
Okay.
look at it.
All right, I'll send after
All
class.
right. Yes. So these are 10 questions that you can do for practice.
stuck from question 7 onward.
What happened?
I cannot do from 7 onwards.
All right, are you done with 1 to 6?
Yeah.
All right, can you check?
Okay. It's only 1 over x
Yes. 1
or
over
1
x
over.
to the power.
Okay.
Yeah?
Yeah, I got it.
All right. So tell me, what is the power of under root? If I
1
want to
over.
write 2 under root, yeah?
Yeah. So
What's
1
the
over
power?
2.
Yeah. This is how you're supposed to solve this also. So it's 1 over what? Under root means that there's a 2 over here, yeah?
Yeah.
Cube root means there's a cube over here. Yeah? Why do we put this 1? Because the power of 2 is 1.
Okay.
Yeah? And we
Yeah.
put this 2 because the power of the under root is 2.
Okay.
Alright? So for example, I have 2 square or 2 to the power 4, 3. Cube root, yeah? How would I
Yeah.
write this as a power? First, in the
1 over
numerator,
2.
the power of 2 comes. And in the denominator, the power of the under root sign comes.
Right. Okay.
Similarly, over here, what I can do is, first of all, I can write this as 7 squared. Yeah?
Yeah.
Initially, if I want to write this as a power, the power of the 7 will come, which is 2. And then the power of the under root sign comes, which is 8. Understand?
Yeah.
Can you
Got it.
try solving 8, 9, 10 like this?
Okay.
Why weren't you able to do 8?
I I wrote 8 over x to 8 x 3 over 2
Okay.
and over 4 x square, and then I didn't know um how to go on with
Okay.
that.
If the bases are same, the bases are same
Yeah.
and they're being
Well,
divided, which means the power will be
uh,
the
the
power
above
will be
minus.
subtracted. Yeah. This is
Yeah.
4 ones are 4 twos are. So power will be subtracted to 2x 3 upon 2 minus 2. Yeah.
Yeah. Okay.
Do you understand?
Yeah.
What is 3 upon 2 minus 2?
Um.
Minus half.
Minus. Yeah.
So how can you write this as 2 upon x to the power half? You need to bring it in a form where there is everything is simplified. All right.
All right. Got it.
Try doing a 9 and 10 now.
Okay. At 9, there are no variables, so we'll just calculate 8 to the power 5 over 3.
So how will we do Yes, we calculate a to the power 5 over 3, but how can we write this? Can I write this as a
Okay.
to the power 5 cube root?
Mm. Yeah.
Yeah. Then you
Yes.
can solve it also.
Okay.
Now answer will be 22.
32. Yeah.
Yes.
Yes.
But this is a step that you will need to do to get marks.
Okay.
Okay.
Got it. Yeah. Understood. I think the last is 64. To the power a over b.
64 to the power a over b. Can
Yeah.
we not further simplify it to be 8 to the power 2a?
Okay. Yeah.
Yeah. We need to
Yes.
simplify it as much as you can.
Okay.
So 8 to the power 2a upon b. Understand?
Yes.
Let's do some more questions so we can have a better understanding. When is your school starting, Anusha?
Um, 27 August,
All
around
right.
that time.
Just give me a minute. I'm getting you questions.
for question 11, I simplified it.
Yeah.
I've simplified it and I got x cubed over 3x to the power 10 and y to the power 5 over 2y cubed.
Let's
so,
check it once you're done with all three questions. Are you done with all three?
no.
Okay, try to do all three and then we'll check.
All right. Okay. Right. I'm done. Hello.
Yes.
Yeah, I'm done.
All right. So this would be 5 ones are, 5 twos are, 4 ones are, 4 threes are. Yeah.
Yeah.
3 minus 10 would give me x minus 7. Yeah.
Yeah.
5 minus 3 would give me y squared upon 2 and 2, 3. Yeah.
Yeah. Okay.
Y
Yeah.
squared upon 6x 7. Did you get this?
Okay. No, I didn't multiply it afterwards.
All right. What did you
Okay.
get for question 12?
Yes, I got 8 to the power 3y over x.
3y over x. All right. So we know that cube root of 5, 8 cube is 512, yeah?
Yeah.
This would be multiplied by x.
Okay. Yeah.
Did you do this?
No.
Where did your 3 go then?
I took it inside. I did 8 to the power 3y. I didn't
No,
write it
no.
with x.
You can't do 8 to the power 3 by, you will multiply it with this power. Or what you can do is, to avoid confusion, let me tell you something else. Wait. First, what you can do is you can solve the inner bracket, all right? So you know that 5 and 2 is 8 cubed, so it would be 3y.
Yeah.
Then what you can do is you can write this as a power. So it would be 3y upon x cubed. Then you can simply just multiply the power. So it will be 3 3s as 9 upon x. You understand?
Okay, yeah.
What did you get for this question?
This too, I didn't do it after simplifying.
Okay,
Like
can you
question
try to
11.
make the bases the same?
Yeah,
So it will be 5x, 5 squared x squared, yeah,
yeah,
into 5x cubed upon 5 cubed to the x 5, yes?
yeah,
Can I write it like this?
yes,
Now the bases are the same. Now you will apply Bodmas, all right? According to, you know what Bodmas is?
yeah.
According to Bodmas, do you divide first or multiply first?
Divide.
You divide and then you multiply, all right? So
Yeah,
make sure you follow this. So what you do is the bases are the same for 5, yes? So
yeah.
first you divide. So what you can do
5.
is, you can divide first, but you don't need to use Bodmas. What you can do is, you can simply solve the numerator first and divide it with the denominator, all right?
All right, okay.
So 5 square into 5 would give you 5, and you will add the powers. Yeah, this is what we did over here in the first rule.
Yeah, yeah,
Yes.
yes.
When the bases are the same, we add the powers.
Yeah,
Okay, and we have 5 cube in the denominator. Again, the bases are the same in x. Yeah.
yeah.
So first we can add the powers. So x2 plus 3 upon x5.
Okay,
So 5 cube upon 5 cube would give me 1. And x to the power 5, x to the power 5 would again give me 1. So this would be your answer. You understand?
yes,
Are you clear till here?
yeah.
All right, great. Okay, now let's
Can I
move
see
on to
the answer for question 12?
yes, yes, yes.
Nine y over x, shouldn't it be 27 y over x?
Can you speak louder? I can't hear you.
The answer you wrote is 8 to the power 9y over x. Shouldn't it be
Yes.
27y over x because it's cubed?
So whenever you tell me, whenever we have a m to the power n, powers
Okay, we
become
multiply.
multiplied.
Yep.
So 3
Yes,
will
yes.
be multiplied with 3.
Okay, got it.
Yeah.
Yep.
Let's move on to exponential functions. Now we will be looking at the curves for exponential. All right. Do you know what exponential means?
I think so.
What does it mean?
Um, I don't know.
Exponential. Have you seen e in your calculator?
E,
Yeah.
yeah,
Have you ever used e?
no,
No. So this e is basically the exponential.
okay,
All right.
yeah.
E stands for exponential. Whenever we write e, do you know what pi is?
Sorry, what?
Pi.
Yeah,
Pi has some value, yes?
yeah.
E is very similar to pi. E also has some value. Can you just put e in your calculator to the power 1?
Okay, I got 2.718.
Yes, this is the value of e. So now
Okay.
we'll be talking about this e. This whole chapter is regarding this e, all right?
Okay.
Okay. So let's look. Now this E has some curves. All right. Let's talk about these curves first. So the exponential function for EX, all right, a positive value EX, all right, the power is positive. So for this, the shape of the curve is like this. It starts from the x-axis, from the left side. It goes up and it keeps going up. It's an infinite function. Now there are two things you need to remember. All right. Firstly, this never stops. Okay. It goes up to infinity.
Right.
Second thing you need to know is, this is the first thing. The second thing you need to know is, this line will never touch the x-axis. It will come very close to the x-axis, but it will never touch the x-axis. It's called an asymptote. Have you ever heard of it?
Yeah.
It's called an asymptote. Why? Because it never touches the x-axis. All right.
Yeah. Okay.
So this is the graph for EX. All right. Let's
Okay.
talk. This is what you have to see. This is a positive x value. All right.
Okay.
Let's talk about E minus x. So now what you're looking at, there is a negative in the power, all right?
Okay.
So whenever there's a negative in the power, what happens? It's a reflection in the y-axis. What does a reflection in the y-axis mean? Let's look over here. So reflection in the y-axis basically means you're keeping a mirror in the y-axis and reflecting it. All right?
Okay.
So whenever there is a negative power, it is a reflection in the y-axis. So this means that initially our EX graph was starting from left. Now this will start from the right and it will go up and keep going up. What we did is basically, this is the graph for EX. Yeah?
Yeah.
Yeah?
Yeah. Yes.
We kept a mirror over here in the y-axis and reflected it.
Okay.
So this part comes over here. This part reflects over here. And this part reflects over here. Do you see?
Yeah.
What another thing that you need to remember is, it crosses the y-axis at 0, 1. All right. This is the third thing you need to remember. It crosses the y-axis at 0, 1. All right.
Okay. Okay.
Understand? Okay.
It
Now we
always
talked
crosses
about,
with this.
yes, it will always cross over here
Okay.
as long as it is EX.
All right.
Now, while we're talking about this, this can also be, this is for all exponentials. All right. It will not only work for E. Even if they give you a graph for y is equal to 2x, this would be the same graph.
Yeah.
All right.
Yeah.
Or y is equal to 3x. As long as there is a power, it will be the same graph. All right.
All right. Okay.
If it's a positive power, this would be the shape. If there's a negative power, it will reflect in the y-axis. Understand?
Yes.
Okay. Let's look at the third graph. So now we have a graph for y is equal to minus e to the power x. Now there is a negative function. There's a negative in the function. The e itself is negative. The power is not negative, all right? So when this happens, it becomes a reflection in the x-axis.
Okay.
All right?
Yeah.
Let me just write this down. All right, what does this mean now? Initially, my curve was like this. Yeah.
Yeah.
All right. So initially your curve was like this, where you have, yeah, EX is like this.
Yeah.
Now the basic EX curve is negative. So it reflects in the x-axis. So you keep your mirror in the x-axis now.
Okay.
All right. When you
Yeah.
keep your mirror in the x-axis, this part reflects over here and this part reflects over here. So where it crosses the y-axis, that also changes to from 1, 0 to 0, -1. Understand?
Yes.
Are you clear till here?
Yeah.
First it was crossing over here at 0, 1. Now it crosses at 0, -1. Okay?
Yep.
There are 4
Yes.
basic graphs that you need to know. Other than that, you will be able to manipulate them.
Okay.
The fourth graph is this. Y is equal to E minus x. So we talked about E minus x, we talked about E minus EX. Now we're talking about minus E minus x, all right?
Okay.
Now let's interpret this first. So we can see initially that this minus means it's a reflection in the x-axis.
Yeah.
Yeah, because there's a minus in the function.
Yeah.
Now what is it reflection of? It's a reflection of E minus x graph. It's not a reflection of EX, it's a reflection of E minus x. So where is E minus x? This is my E minus x graph.
Okay.
Can you see?
Yeah.
The shape was like this. Now this is being reflected. Understand?
Right. Okay. Yeah.
Does it make sense?
Yes, it does.
Okay. All right. I'm sure you have done trigonometric graphs.
Yeah.
Yeah, so you must know how we manipulate these graphs when there is a change in the magnitude or there's a plus or minus sign.
Yeah. Okay.
Yeah, let's talk about that. Actually, let's stop over here today. We will be having our next class where we'll be discussing all the modifications in these graphs. All right, I feel like if I give you more information on these graphs, you'll get a little confused. So what I want you to do right now is I want you to go through these graphs and I'll give you some questions for indices as homework, all right? In the next class, what we'll do is we'll talk about all the modifications in these graphs, all right?
Okay. Got it.
All right.
Yes.
Okay, does that sound okay with you?
Yes, it does. I'm fine with it.
Okay. All right, let me just stop the recording.